Hey everyone, welcome. You ever stop and think about how the software on your phone or your computer, well, thinks? It feels like it's making decisions, right? Well, today we're going to pull back the curtain and show you exactly how the programs you use every day make choices. It's actually simpler than you might think. Let's dive in.
It really all boils down to this one question. When you tap a button or type something in, how does the software know what to do? It's not some kind of magic. It's all about logic.
You know, the best way to picture this is to think about a host at a restaurant. They don't just point you to a random table. Nope, they follow a simple set of rules. Are you a party of one? Okay, you go to the counter. Party of two? Let's find you a small table. Anything bigger? You're getting a large table. Computers do the exact same thing, they just use data instead of people.
So this whole process of choosing a path based on some kind of rule, it has a name in the programming world. It's called branching. And trust me, it's the absolute foundation for how all software makes decisions.
So what is a branch, really? Well, at its core, it's just a chunk of code, a set of instructions that the computer will only run if a specific condition is true. If that condition is false, the computer just skips right over it and keeps on going.
Let's start with the most basic kind of decision a computer can make. This is the simple if statement. All it does is check one single condition, and if and only if it's true, it follows one specific path.
Here's a perfect everyday example. Imagine a hotel booking website. It needs to figure out if it should give you a senior discount. The only thing it cares about, the one condition it's checking, is your age.
Okay, so check this out. This flowchart here is basically a map of the program's brain. You can see how it works, right? It starts, it gets the user's age, and then bam, it hits that diamond shape. That's the decision point. And right there, it asks one simple yes or no question. Is the age greater than 65?
All right, now let's play along and be the computer for a second. The input we get is 68. So the program asks its question, is 68 greater than 65? Yeah, that's true. So we follow the true branch on our map, and that leads us straight to applying the senior discount. Simple as that.
And this shows you exactly why that single if is so powerful. When the age is 68, the condition is true, so that discount code runs, and you get the lower price. But when the age is 50, the condition is false. The program completely ignores that discount code. It just skips right over that branch. See the difference?
But what if you want the computer to do something else when the condition is false, instead of just, moving on? Well, that's where our next tool comes in. It's called the if-else statement, and it gives the program a totally different path to take.
With an if-else, the computer has to make a choice. It's a this or that situation. It checks the condition. If it's true, it runs one block of code. Else, if it's false, it runs a completely different block of code. It always has to pick one of the two paths, no exceptions. Okay, let's take a look at an insurance company's website. They have to set a price based on risk, right? So the big question they're asking here is the user's age less than 25? And this one question is going to lead to two very, very different prices.
And this table here makes it crystal clear. If you're 18, that condition, age less than 25, is true, so you go down that path and bam, you get the $4,800 price. But if you're 25 or 30, the condition is false. So the program has to take the else path, which leads to the lower $2,200 price. All right, so we've got one choice down, and we've got a this or that choice. But what about real life, where there are often 3, 4, or way more options? Well, that's when we start chaining these decisions together.
Let's go back to our amazing restaurant host. Their thought process is a perfect real-world example of this whole structure. First, they check if the party is one person. If it's not, they check else if the party is two people. If neither of those is true, they just default to the final else option, seat them at a large table.
And here's what that looks like as a program. This flowchart is checking the number of years for an anniversary. It asks, is it 1? If not, is it 25? If not, is it 50? It's like a waterfall of questions. It just keeps checking down the list until one of them is true, or it just runs out of questions to ask.
So the program is only ever going to pick one of these outcomes. If you type in 25, it skips the first check, gets a yes on the second one, prints silver, and then it's done. It jumps all the way to the end. But for any other number, like say 10 or 32, it's going to fail all the specific checks and land on that final else branch, which just prints congrats.
So, we've looked at some pretty simple examples, right? A hotel, an insurance company. But why is this stuff so important?
Well, it's because these exact building blocks are quite literally running your entire digital life.
And here it is, the main takeaway. Every single time an app or a website does something that feels intelligent or that responds to you in some way, you could bet it's using these fundamental if-then-else rules under the hood.
And you see it absolutely everywhere. When you log in, if the password is correct, let me in, else show an error. In a video game, if the jump button is pressed, make my character jump. Applying a promo code, your GPS recalculating your route when you take a wrong turn, it's all just branching logic.
And that's really the magic of it all. By just combining these simple, logical forks in the road over and over again, developers can build these incredibly complex systems that react to you and the world around them, making them feel dynamic and, well, pretty darn smart.
So, I'll leave you with this thought to chew on. As you're watching this, as you're browsing the web later, or using an app on your phone, just take a second and think, what decisions is this program making about me right now? It's kind of wild when you really think about it. Thanks for tuning in.